Hello, we're going to be starting Module 14, which is scatter plots. And Module 14 has two different parts. We have scatter plots and association, and we have trend lines and predictions. So we're going to start off with the Are You Ready? So basically for the Are You Ready, all you have to do is plug in your X and solve for the problem. So for the first one, 6x minus 5 for x equals 4. So all we have to do is plug in a 4 for our x. So it would be 6 times 4 minus 5. And then just solve it. 24 minus 5, 19. That's it. Same thing for 7 through 14. So what you're going to do is, this is just a two-step equation. So 3x plus 4 equals 10. So we've been solving these all year, so you guys should be fine with that. Minus 4, 3x equals 6. And then divide by 3, x equals 2. So there's the answers. You guys should be fine with those. All right, so here is the reading startup. So the y equals mx plus b comes back in this module, so I hope you remember what your slope and your y-intercept and what the m and the b are. So here the y equals mx plus b, that's your slope-intercept form, or a linear equation, linear being a straight line. Your y is your y-coordinate, your m is your slope, your x is your x-coordinate, and your b is your y-intercept. This should all be reviewed, should all be in your notes. All right, so here's some vocabulary that we have that we'll go a little more detail when we get to the lesson. But the first one's a cluster, which is a set of closely grouped data. Next one is outlier. Think about outside. It's a data point that's very different from the rest of the data set. It's outside of that data set. And then a trend line would be B. That's a straight line that comes closest to the points on a scatter plot. And we'll talk about trend lines in 14 too. All right, so scatter plots and associations. So for the activity 1, it says, recall that a set of bivariate data, bi being 2, involves two variables. Bivariate data are used to explore the relationship between two variables. You can graph bivariate data on a scatter plot. A scatter plot is a graph with points plotted to show the relationship between two sets of data. You don't have to connect any dots, it's just plotting these points. So if you look here, we have hours spent studying and test grades. So the final question on a math test reads, how many hours did you spend studying for this test? The teacher records the number of hours each student studied and the grade the student received on the test. So if you look here, we have hours spent studying, and that's going to be on your x coordinate down here. And then we have the test grade, 75. So what we're going to do is take your first one. They didn't study at all, so 0 hours, they got a 75%. So we're going to put a dot right there at the 75. The next one, studied for a half hour, got an 80. Studied for 1 hour, 80%. 1 hour, 85%. 1.5 hours, 85%. So this is a scatter plot. So make a prediction about the relationship between the number of hours spent studying and the test grade. Usually, the more you study, the better your grade is. So what trend do you see in the data? The more you study, the better your grade is. See how it's going up. So the more you study, the better your grade. Do you think the grade associated with studying for 10 hours would follow this trend? Yeah, I think if you studied for 10 hours, your grade would be pretty high. Not guaranteed, but if you're studying correctly, then you should be all right. But you're not going to get higher than 100%. All right, so the next part, we're going to talk about clusters and outliers. A cluster is a set of closely grouped data. If you've ever shot a gun, a bow and arrow, or anything at a target practice or played darts, whenever they're grouped really close together, that's called a cluster. So like there's a cluster right here, and looks like a cluster right there. An outlier is a data point that's very different from the rest of the data set. So, if you have a data set like somewhere out here, that would be an outlier. On this problem, that is an outlier, and we'll talk about why it is. So it says, a scientist gathers information about the eruptions of Old Faithful, a geyser in Yellowstone National Park. She uses the data to create a scatter plot. The data shows the length of time between eruptions and how long the eruption lasts. So describe any clusters. It looks like at about 50 minutes, it lasts about 2 minutes. The next cluster is about 80 minutes, is anywhere from like 3.5 to 5 minutes. So that would be a cluster. The only outlier I can really see is at like 60 minutes, it went off for 3 minutes, when nothing, it usually doesn't happen around that time for that long. So that could be an outlier. All right, so now we're going to talk about association. So association describes how sets of data are related. And there's 3 different ways it can be associated. We have a positive, which is when both data sets increase. So as this one's going up, this is going up, so that is a positive association. Now this one is this is a negative association. This would be like the value of a car, how many years you've owned it. The more you've owned the car, the less it's worth, unless you have a classic car or something fancy. And then no association would be like your favorite color being blue and your IQ. Just because you like blue doesn't mean you're very smart, or just because like you like yellow doesn't mean you're not very smart. So those are your 3 associations. Example 1, Susan asked 20 people if they would buy a new product she developed at each of the several prices. The scatter plot shows how many of the 20 said yes at a given price. So she's selling this thing for $2. All 20 of them said they would buy it. Now, as the price goes up, the amount of people that buy it goes down. So that would be a negative association. As the price increases, the number of buyers decrease. So there's a negative association because the data points do not lie along a line. The association is nonlinear, so it's not a straight line. All right, so what if, based on the association shown in the scatter plot, what might happen if Susan increased the price to $14? So if you look at $12, only 2 people would buy it. If it went up to $14, you could have 0 buyers. I would say 0 to 1 or 0 to 2 buyers would buy the product. All right. So for the your turn on number 6, it says the plot shows the reading level and the height for 16 students in a district. Describe the association and give a possible reason for it. So this is talking about 40 inches to 60 inches. 40 inches is like 3'5", 3'6", or 3'4". So 40 inches is 3'4". So you're probably in maybe kindergarten at that time. And then 60 inches is about 5 foot. So you might be, roughly in middle school at that time. So does your reading, hopefully your reading level from kindergarten to middle school has gone up. So I would say it's got a positive association. And that's about it. So if you guys have any questions about this, please reach out through email and I'll get back to you as soon as I can. Thanks. Have a great day.